All right, so this is the midterm review. As announced last week, and I sent out a reminder this morning. The midterm opened up at 1 second after midnight this morning. It's been open and will be open until 1 minute or 1 second before midnight tonight. You have a 24-hour window, which is now down to what? Like 2.5, so 9.5 hours left. Right. I did not look at the numbers for how many people have put stuff in yet, but there have been no questions on Piazza, so I assume that everything's going well. Same format as exam one, of course. All the files are right here, along with the handout on what you're supposed to do. There's no collaboration, of course, with any individual inside or outside. If you chose to come to lecture today, great. Or if you're live streaming at home, great. We're going to be doing a review. The review is simply going to be the midterm from spring. And we'll do everything from that midterm. If you want to use this time instead to actually do the midterm, then go ahead. You're free to do that. But it is due tonight at midnight. Of course, regular help hours have been held today. The LAs just won't be able to give you the same amount of the same level of help as they would on a hack or a lab. Right? We're online, so if you have any questions, you can go ahead and post to the YouTube live stream here. But otherwise, here's the midterm exam from last spring. The first one is very, very similar to that other review I did right after, I think, Lab 6. Where you are given an amount in one unit and you're asked to convert it to the other units. In fact, is this what we did? I forget. Does anybody remember? We've still got it here. What was in the review? Oh, it was mass. All right. So instead of mass, we're doing energy, right? You can convert from joules to calories to BTUs, British thermal units, or to foot-pound force, right? Different scales using these three conversion features right here. So you just have to write this one function to convert from joules to these other three. Do we want to do that, or do we want to focus on the array stuff first? We'll have time to do it all, probably. Oh, just go down the line? All right. All right, so convert from joules here. So I'm going to go ahead and put the prototype along with the documentation in my header file here, right? And I'm not going to go ahead and do the full documentation here, and I'll just say to do documentation. Now, in your actual exam, you are expected to have documentation there. It doesn't have to be long. Don't make it long. It's not an essay. Just have some basic documentation. Every prototype needs documentation, okay? But otherwise, there's the prototype in the .h file. Over here in the .c file, I would need to include that header file, midterm.h. Okay. A lot of this boilerplate is given to you in some of the functions if you haven't started already, but you'll find it there. What's the very first thing you do in a function before anything? Error handling, exactly. And among error handling, what's the very first type of error you do? So what's the first of the first? Check for bad pointers. And what are the bad pointers? Null. So if calories is null, and it's already a pointer, so you don't dereference it. If you did dereference it, first of all, that's a regular old variable, and regular old variables are not null, but then you're also dereferencing it before you even check for null, right? And then Bret Hart comes out of the computer and knocks you over the head. Don't dereference null pointers. Or BTU is null, or is this large enough? I can go, oh, that's way too large. There we go. Or foot-pound force is null. If any of those things happen, we need to return a non-zero error code here. Right? So in this case, I'm just going to return 1. You can come back and you can use the defines. You can come back and you can write your own enumerated type as long as it's correct, right? That I don't think that we directed you to do either one here, but I don't know. This is last year's anyway. This is last semester's, okay? But we're returning a non-zero error code here. Are there any other types of errors that we should be aware of here? Negative values. Can energy be negative? No. Relative energy can be negative, going from a high energy system to a low energy system, but there's no such thing as, wouldn't it be wonderful if there were like a chocolate cake that was negative 500 calories, right? Something that took away energy instead. That doesn't happen, right? Else if joules is less than 0, then we'll return another non-zero error code 2 here. And again, this is where you can come in with a different enumerated types or defines or whatever, right? Otherwise, I'm going to do my stuff down here, but then what do I return in the event that there's no error? 0. Always 0 for no error, okay? Now I actually need to do the work. I know that they're not null, so I can dereference them and set them equal to whatever the conversion is. Calories is equal to, what was it? Whatever this is. Copy, paste this. 1 joule, joules, times that amount. If you wanted to put that amount into a constant, if you wanted to put it into a define, go ahead, do that. If it were a regular hack, we would probably really strongly urge you to do that. If it's just a one-liner here, maybe, I don't know. The important thing here is this a correct line of code? That thing on the left-hand side is what kind of variable? A pointer. The thing on the right-hand side is a value, right? If I multiplied it by 10 joules, it would be 2.3 calories, right? So the thing on the left-hand side is not a regular old variable. What do I do to a pointer variable to make it into a regular old variable? I dereference it because it's already a reference, and that is the asterisk. Right? Again, that's your post-it note. Just put it up on a post-it note. Right? Calories, BTU, and foot-pounds are similar, except that they are different numbers. Here's BTUs. Cut, paste, cut, paste. There we go. Done. Now, why did we pass everything by reference? All this, these three were passed by reference, right? And this one was passed by value. The value of the joules is passed. Right? Why did we do this to begin with? I want to convert from one value, joules, to 3 other values. If I just use regular old functions, what do I need to do? I need to write 1, 2, 3 functions. Joules to calories, joules to BTUs, joules to foot-pound force, right? But this way, I have 3 buckets, 3 passed by reference values that I can return 3 values. You can't do that with a regular function, right? Regular function, if you reuse the return type, it only returns one thing and one thing only. Because functions in computer science, just like functions in math, have to pass the vertical line test. You can only return one thing, period. Okay? Let's test this really quick. And to do that, I'm going to have some values here. So I'll just make an easy one. If I have double joules 10, right, then it's going to be really easy to determine if these are the correct numbers. Simply multiply each one of these by 10. Right? This is a nice, easy test case for me. But of course, I will also need values to hold BTUs, what was it, calories? BTUs and foot-pound force. There we go. Now let's call this function. Convert joules from joules to these other 3 right here. There we go. And you can also capture the return code here if you want to and print it out, just to test it to make sure that it works. All right. So printf blank f joules to is blank f blank f blank f. Right. And with code %d end line. So I will print out joules, calories, BTUs, foot-pounds, lengths, and then finally the code, just to make sure that everything works here. This is a very quick, dirty ad hoc testing where I'm just going to print everything to the output. Is this how I call this function, though? So remember, the first one is passed by value, joules, but the other 3 are pointers, pointers, pointers. So is calories, BTU, and foot pounds here, are those pointers? Nope, they're regular old variables. So just the opposite on your post-it note. How do you take regular old variables and turn them into pointers so you can pass them by reference? Ampersand, ampersand, and ampersand, just like scanf. Okay. How do I bring all this stuff together? How do I compile all this stuff? I need to compile my library, my midterm library, and so I use the -c flag, remembering that I should always, always, always use the wall flag to determine if there's any warnings that I can take care of immediately, and midterm.c. There we go. Uh-oh, thank you. There is a note. In fact, it's a full-on error here in my midterm.c. What is it complaining about? Null. Where is null defined? In the standard library. So let's include the standard library. You should do that anyway, no matter what. Now, do I need to include the standard input-output library in this file? Do you see any printfs, scanfs? Nope. Do you see any math other than the built-in multiplication? Nope. So we should be good to go at this point. And we are. Good. That produced a midterm.o file. GCC midterm.o and midterm.test.c. Right? Again, don't forget the wall flag. The wall flag will tell you if there's any warnings. And there are. Thank you. Implicit declaration of convert joules. What did I forget to do over here in my midterm test.c? I included the standard library. I included the standard input-output library because I'm doing printf stuff. But what did I not include? My library. Include midterm.h. Okay? That gets rid of the warning and compiles everything into one file, a.out. 10 joules is 2.39 calories, 0.09, is that correct? It looks like it to me. There were 3 zeros before and then 7.3 something, yep, with code 0. Go back, change the values, pull out your calculator, make sure that it works. Try some bad values. What if I gave it a -10? We should not expect any actual answers, but we do get an error code of 2, right, for a negative value of joules. If you want to, you can go ahead and explicitly pass in null. Right? And of course, this will work too. GCC, a.out. Yeah. There we go. Error code 1. Right? Undo that. Calories. There we go. All right. There's the first one. Questions on that? Otherwise, it's all exactly the same as the mass one that we did a couple weeks ago. Mass. Yep. Except it was converting from kilograms to pounds, ounces, and newtons. Right? Okay. In this part, you'll write several functions that operate on arrays. Implement the following functions that all operate on integer arrays in particular. Only are supposed to have values 0 and 1. We call those bit vectors, right? Such arrays are called bit vectors. So it only includes, it's an array of elements, but it only has 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, right? If it has 2, or if it has 5, or if it has -3, or even -1, those are not bit vectors, okay? So write a function that computes the parity of a bit vector. So given a bit vector, for example, like this one, what you do is you go through and you count up the number of ones. In this case, there's 1, 2, 3, 4, right? That has 4 ones, and therefore it has an even parity. There are an even number of ones, and its parity is 0. In this example, 0, 1, 1, 1, 0, 0, 0, 0, it has 3 ones, and so therefore it has an odd parity, and it has a parity of 1. Right? 0 for even, 1 for odd. We're going to write this function here that computes the parity given this bit vector of length n. So all we need to do is go through, count up the number of ones. If the number of ones is even, then we place 0 into this pass by reference variable here. If it's odd, we put 1 into this pass by reference variable here. Right? The return type here is used for any error codes. Okay. So let's come back over here. And I'm just going to put this in the same header file. Again, write your own documentation. Right? And let's go ahead and implement this. All right. Again, what's the very first thing I always do? Always, 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 every function? Error checking, right? And what's the first thing I do in there? Very first thing I do when I do error checking? I check that pointers are valid. Right? If the bit vector is 0 or null, right? Or the parity, parity is null, then I'll return a non-zero error code. I'm just going to roll all of the errors into one statement here, though. What else could go wrong, say, with n? Sorry, n is the length of our bit vector here. Right? So in this case, n would be 0, 1, 2, 3, 4, 5, 6, 7. Right?
What if n were negative?
What if n were negative? Right? Then we could get away with, well, by saying, well, that's going to be an even parity or something like that. I'm just going to go ahead and return a non-zero error code here saying that's not well defined. Don't ask me that question, right? Ask me a better question, right? I'm the function now, right? All right. Otherwise, home row, return 0. There we go. Now let's actually do the work. I'm going to iterate over the bit vector, right? And if it is 1, add it to a running total, right? If it is 0, ignore it, right? If it is anything else, error. You gave me a bit vector that was not a bit vector. It has 42 in there, right? So I'm going to go ahead and return an error code in that case. Translate each one of these lines. If I'm going to iterate over an array, it's just an idiomatic for loop. For int I equals 0, I is less than n, I plus plus, right? Okay. No commas. Right? Be careful. Common errors would be just mashing the keyboard and doing it wrong, or 0 is equal to 1. Well, 0, that's definitely a compiler error. Well, most of these are going to be compiler errors here. But I is equal to 0. You always start out at 0. You go up to, but not including the size of the array. Okay? Now, if it's 1, I add it to the running total. So, if, what did I call it? Bit vector? Bit vector sub I is 1, is 1. Then I will add it to the running total. Add it to the total. ... Okay. That means I need a variable to hold the total, right? Int. What should I call this variable? Counter? Okay. What is it counting, though? It's counting the number of ones, right? So why don't we just call it that? Num1s. Right? There we go. Before I continue, did I just do something wrong on line 26? Did I omit something?
Yep.
What's in there? What's in that variable right now?
Dead beef.
Dead beef, who knows? Garbage. Garbage plus 1 is garbage. So, what should you do? Initialize it to 0. Okay? All right, add it to the total. That's pretty easy. If I just want to add 1 to num1s, what would it be? Plus plus. That'll get the job done. You could go num1s is equal to num1s plus 1. Right? You could go num1s plus equals 1. Or you could just go plus plus. If it's 0, ignore it. Okay, well, if I were to write it like that, else if bit vector of I is equal to 0, ignore it, ... Don't do anything, right? It would be dead code. There we go. Don't do anything. Else, it must be something else. It must be something not 0 nor 1. That's going to be an error, right? So I will immediately return here with an error code of 2 because I've already used 1 up here. Right? You gave me something that was not a bit vector. That takes care of everything down here. I really don't like that blank there. Is there a way that I can consolidate my logic so that I'm only doing 2 checks? So let's walk through this from line 28. If it's 1, I increment my counter. Okay? Otherwise, if it's 0, I don't do anything. Otherwise, it must not be 1. Otherwise, line 29 would have executed. So it's not 1. If it's not 0, then it must be something wrong. Right? So if it is not equal to 0, then I can go ahead and return 2 here. Right? I've consolidated my code. Now, you could write the other code and just leave a blank there, and maybe the compiler would end up compiling that away and optimizing it away or something like that. But this is a little bit better. Right? So if it's 1, you add your counter. If it's not 1 and it's not 0, then that's an error. If it's 0, else if it's 0, then don't do anything. And now you don't need to write that blank block there. Okay? Excellent. That looks good enough for me. Let's come over here to our midterm test and create an example that we can run really quick here. Like this one right here. So that's going to have 7 values in it. Int vector is equal to that thing right there, 0, 1, 1, 0, 1, 0, 1. Right? Let's call our compute parity on our bit vector of size n, and we need a parity value right there, int parity. And then we'll print it out. As I'm printing this out, we're writing this code, look at line 16 and tell me if there's something wrong. Is there? Yep. No ampersand on parity. Parity is a regular old variable. What does this expect? A pointer. So, taking a regular old variable and making it into a pointer would be ampersand, just like scanf. There we go. Compile everything together again. Again, we made changes to all of these files here, so you do need to go back and recompile midterm.c. Then you can recompile everything together and run it, and the parity is 0. Right? Is that what we expected? 1, 2, 3, 4 ones. Yep, the parity is 0 there in the handout. What about this one? Parity is going to be 3, therefore it should the number of ones is going to be 3, and therefore the parity should be 1. Oops. Did I not save it? Save. Oh, come on. Oh, yep, good. Did we ever set the parity, by the way? I can't believe I forgot that. This is why we do testing, even ad hoc testing. The ad hoc testing is a sanity test, right? And clearly I'm insane right now because I forgot to do the basic thing, right? Did we ever actually do anything with this variable? No, I just counted up the number of ones. What should I be doing at the end? Right? If the number of ones is even, set parity to 0. Else, if the number of ones is odd, set parity to 1. Translate that to C code. If num ones is even, how do I determine if something is even? Divide it by 2, take the remainder. What should the remainder be if it's even? 0. Right? Parity is equal to 0. As I'm writing the rest of this, tell me, is that correct on line 38? And is it correct on line 40? What kind of variable is parity? A pointer. In order to set its value, what do you have to do to it? Dereference it. Dereference it. Now you can get clever here with the ternary operator or something like that. I'm not going to get clever. I want to get it done. Clever code, smart code. Tricks are for kids, right? You want maintainable code above all else. You want readable code, understandable code. That's much better than clever code that does everything in one line instead. Right? Parity's 1. Looks good to me. Right? Hand it in, partially test it as you go along if you want. You've got 9 hours left, right? To test it as many times as you want up until that due date. Okay. Write a function to compute the Hamming distance of 2-bit vectors of the same length. The Hamming distance is the number of positions or bits in which the two vectors disagree, having different values. For example, if I have those same 2-bit vectors as examples from before, 0110101 and 011110000, right? Then they differ in 1, 2, 3 different positions, right? Those are the ones that are bolded. 011, they both agree in those first 3. They disagree in the 4th, 5th, and 7th positions. Right? One is 0 and the other is 1. Count up the number of ones, or count up the number of positions in which they differ, and that's called the Hamming distance. And by the way, none of this stuff is made up. This is all used in checksums, in coding theory. Not coding theory as in coding like you're writing code, but coding theory as in you are adding redundancy to data so that that you can correct errors in transmission. And Hamming distance is vital to stuff like that. Right? So is the parity. Right? That's just a basic checksum. Right? Okay. So I'm going to write this function right here. It takes 2-bit vectors. Right? Let's go over here, put this. And as I write that down and correct for it, there we go. Remind me, why is everything const here? What does const do? And make sure that you can't change it. Right? And so if you're not going to change it, put a const in front of it to advertise and say, I'm not changing this. The lack of a const variable screams out to experienced C programmers that you are probably going to be making changes to this. So I need to be careful. It's not const. You are going to make changes to it. Because you can make changes to it. So I'm just going to assume that you're going to make changes to it. All right. Once again, write your own documentation. That's a to-do. Right? So here's Hamming distance. It takes bit vector A and bit vector B. We assume that they're both of the same length. And then we compute the Hamming distance, put that into this variable here, reserving our return value for any error conditions, which is the first thing we check. If bit vector A is null, or bit vector B is null, or n is less than 0, or ham distance is null, all of those are potential error conditions which we return 1 for. Otherwise, return 0. Error checking done. Right? Actually not, because we do still have to check if it's not an actual valid bit vector, then we would have to return an error code. Hey, we're doing that now twice. Right? Maybe that's screaming out to me that if I had more time, I would go and write another function, validate bit vector, that went through and made sure that there were only 0s and 1s. And if there was anything else, then I would return an error code. I could then call that in 2 different functions. Okay? But I'm not going to do that here. All right. I just need to iterate over the elements. And if different, increment a counter. Right? Then make sure to, if they are not valid bit vectors, return, 2. Right? And after I'm all done with that, I make sure that I put the Hamming distance into that variable. Don't make the same mistake that I made up here. Okay? All right, iterate over the elements. By the way, is this something that you leave in your final submission? Nope, that was whiteboarding stuff, right? That is a cruft comment that should be cleared out, right? It's garbage. These are cruft comments, right? The code is self-documenting. Everybody that looks at these lines of code knows that you are checking to see if it's even or not, right? All right. Iterate over the elements. For int I equals 0, I is less than n, I plus plus. The idiomatic for loop here. Right? if the bit vector value stored in I is not the same thing as the bit vector B, I, A and B here, there we go, then they differ, right? If different, increment a counter. Hey, wait a second, ham distance. That's my counter, isn't it? Could I do something like this? Ham distance plus plus. What kind of variable is ham distance again? It's a pointer. So if it's pointing to memory location 42, what does plus plus do? Makes it now point to memory location 43. Doing it again makes it point to memory location 44, 45, 46. It's changing my pointer. Does that sound valid? No. Oh, well, okay. Burke said that if you have a pointer variable, all you need to do is dereference it, right? That ain't going to work either. Right? Because if you pull out your big PEMDAS book, right? PEMDAS, parentheses, exponents, help me out, multiplication, division, addition, subtraction, right? Then you've got about 50 other operators that have this entire hierarchy of order of precedence. Which one comes first? The dereference or the plus plus? If it's the dereference, if it's like this, then we're safe. If it's like this, then we're not safe. Does anybody want to pull out their big giant PEMDAS book to find out which one it is? No, I don't. By the way, it's not. It is the bad one, right? This is just as bad as doing something like this, right? What you would have to do is if you wanted to do it this way, you would have to surround that with a parentheses to get it to work. I don't want to have that kind of headache. That's introducing an unnecessary failure point. Just use a regular old variable. Int. Numdiff, right? Number of different bits. Numdiff bits. Whatever you want to call it. Make sure that you're initializing it to 0. Anytime you find two bits that are that are different, numdiff plus plus. Right? Come on. Oh, man. Whoa. Okay, there we go. All right. The network had to think for a while. Right. We didn't get any drops. We're good. It must be the CS50 ID. Okay. So if they're not valid big, okay, I'll take care of that in a second here, but FSDA, that's me mashing the keyboard, trying to get it to work. All right. So numdiff, all I need to do now is set that equal to, or put that into that bucket, that ham distance bucket, numdiff. Is that the correct way of doing it? Pointer on the left-hand side, regular variable on the right-hand side, make the pointer variable into a regular old variable by dereferencing asterisk. There we go. Get rid of unnecessary vertical white space there. I left this off to do. Verify that the bit vectors are correct. Right? In other words, bit vector A sub I and bit vector B sub I should only be 0 or 1. If you get anything else, you should immediately return with an error code. Right? Oops, that's not what I want. Come on. I'll put that up here. Right? And again, you could put that into another function. Let's walk through the logic at least. Right? We've got time. So how do I verify that these two bit vectors are valid? What are valid values? Bit vector of A could be 0, or bit vector of A of I could be 1. Those are okay. Right? If they're not okay, then what do I have? Remember, this is okay. I don't want to return an error code in this case. Right? So how do I negate this? Well, this one's easy to negate, right? If it's not equal to 0, if it's not equal to 1, if both of those are the case, then it's an error. So read that in English now. It's much better, right? if the bit vector bit is not 0, and it's not 1, it must be something else. I return 2, right? That's for A. Now what do I do for B? Same thing, but replace it with B and B. Now I can combine all those things, realizing that I don't need 2 if statements. If I've got 2 independent if statements, how can I collapse that logic down? If this condition holds, or if this condition holds, I return 2 in either case. Right? So how can I bring these two together? Oops, keep pressing the wrong button. Within or. Make sure that you're surrounding it correctly with proper parentheses, and there we go. And now I've got it down to 1. Do I necessarily need to do an else here? No, because if this is true, the entire function is done. It returns immediately. We're done. Okay. So let's come over here to our midterm test, and I'll go ahead and make another vector here, vector b. Right? And let's go ahead and call that function, what was it called? Hamming distance. Hamming distance on vector and vector b, both of size n, and oh, I need the other one now, right? I need this one right here. Or was that the other one? Dang it. Nope, that was this. Okay, so change this one back to the first one. And now you see the frustration with ad hoc testing. It's not repeatable. You have to go in and change stuff. Go in and change stuff, right? This is why if you're going to do it on a real assignment or a real application, you have repeatable tests with formal or informal unit testing. Okay? And then we need a ham distance variable here that I will pass by reference. So I need to create that, ham dist. There we go. And I will print that out instead. Ham dist, there. Let's make sure that everything compiles. Good. Good. And remember that the hamming distance on our example in the handout was 3. Hey, looks like it works. Excellent. Last one. That's it. Given 2-bit vectors, A and B, each of the same length n, the vector multiplication is a new bit vector. Right? So it's a new array of length n, so same length, such that each element in the new array is the multiplication of the 2 elements in A and B. In other words, if this is the new array, then it's going to be AI plus, times BI. So if I have, say, 1, 2, 3, 4, 5, and I multiply it with itself, that's going to be squares. 1 squared is 1. 2 squared is 4. 9, 16, 25. Right? So let's test that. First of all, let's set up our test. Int A is equal to 1, 2, 3, 4, and 5. Right? Int B, same length here. I don't know, 10, 20, 30, 40, and 50. So what should I expect out of this? And I'll reset n here to be 5. What was this called? Vector multiplication. I'm going to multiply A by B. They're both of length n. That was the only thing though, right? Yep. And then it returns a result that I capture as an int star. Then I can go over that and print all the contents of that array. For int I equals 0, I is less than n, I plus plus, print %d space, and c sub I. Right? I wrote my test before my function. That's called test-driven development, TDD, right? Where you write all your tests to make sure that you understand the problem and the expectations, and then you go and you write the actual code, right? Whether or not you do one before the other, who cares? But there are some TDD zealots out there that would say, no, the only way of doing it correctly is to write your tests first, right? Don't listen to them. All right, so let's go ahead and implement this. Once again, we put the prototype along with the documentation. Documentation is to do, and the in the header file, and then we actually put the definition of the function here in the source file. Okay. So, what's the very first thing I do? What is always the very first thing you always do? Error handling. If bit vector, in fact, steal it. Right? Go ahead, steal code from yourself, right? There's still folks that feel uncomfortable about doing that. You wrote it, right? It's yours, exactly. Right? Return 1. Just don't post it until after the midterm is over. Right? All right, so if any of those happens, then we return 1, an error code. Otherwise, we need to return 0. Okay? Now I need to create a new array of size n that holds integers, ... What's that thing I use to create new arrays? Malloc. Int star malloc. How many bits do you want? Do you want n bits? Well, n in our example over here was 5. Right? There are 5 integers. Is 5 bits, or 5 bytes, excuse me. Is that enough to hold 5 integers? Nope. How do you create arrays? Dynamically? Size of int. Right? However many bytes an integer takes, which is usually going to be 4, times the number that you want, in this case 5, right? And that tells you how many bytes you actually want. Right? Oops. We'll come back to this. I'm doing something wrong, and I'll ask you what I'm doing wrong. Right? Now, populate the new bit vector with the multiplication of a and b. Right? So for int I, idiomatic for loop again. Int I is equal to 0, I is less than n, I plus plus. Right? C, the result, is going to end up being bit vector a sub I times bit vector b sub I. It's as simple as that. All right? So that's like taking 1 times 10, which should be 10. 2 times 20, 40. 3 times 30, 90. 4 times 40, 160. Right? 5 times 50, 250. Okay? That should be the result. GC, let's compile it. Okay, all right, ignore that warning. Right? Again, 90% of your problems can be taken care of with that wall flag, and this is one of those. Right? Oops, print f. There we go. All right, ignore those warnings. It actually compiled, it will run. Will it give me 10, 40, 90, 160? No, it'll give me a segmentation fault. Okay? Now, if I had heeded that warning, I would know exactly what the problem is immediately. Right? I mixed up my error handling. Right? But let's take a reminder with 5 minutes here of the tools that we need to determine what the hell happened. So what's the first tool? How do I know where something went wrong? What's that first tool? Starts with a V. Valgrind. Right? Well, first of all, what do I need to do? Compile with the G flag. Again, ignore that error. Right? Compile with the G flag here. Right? There we go. And we're still getting our segmentation fault, but where the hell is it? Valgrind, please tell me. Right? 2 errors from 2 different contexts here. Right? So where is it happening? It's happening, so there were 20 bytes here that were definitely lost. That's a memory leak. That's different than the actual seg fault. There's an invalid read of size 4 on line 28. Line 28 is me printing out the results of that vector right there. Right? So there must have been something going wrong with this vector. What's the second tool that we demoed on Friday that I could use to walk through this? GDB, a.out. I know that something's happening after line 26. So let's go ahead and break at line 26 to find out what the hell is going on. Right? Layout, source. There we go. There's my source code up there. All right? And let's run it. All right, refresh. All right. Now, if I hit next, then I receive this array back. Let's print it out. How do I print an array? You dereference the array. You tell it how big it is. I know that there's 5 here in this case, or it's stored into variable n, right? And cannot access memory at 0, 0. Something happened in that function. Right? We never got our array back from that function correctly. Right? C is an invalid memory address. So let's go ahead and set another breakpoint in that function, vector molt. Right? And let's rerun the program. Right? Yes. All right, and next. All right. And now we're inside that function. Now let's walk through step by step. Let's print out the values that we actually got. Bit vector A at 5. We received 1, 2, 3, 4, 5. Print bit vector B at 5. We received 10, 20, 30, 40, 50. So we received everything correctly. Step next. All right, error checking worked because neither one of those is null. It's not negatively sized, etc. We create that new bit vector. Next, 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 right? I don't want to have to go next all the time, so you can set another breakpoint and continue. But before we go back, let's go ahead and print out C at 5. It indeed is 10, 40, 90, 160, and 250, like we wanted. What am I about to do on line 78, though? I return 0. 0 is being interpreted as null here. And that's why we get a segmentation fault. Okay. We found our bug. Quit out of this. Go back to the drawing board over here. Go into the midterm. And instead of returning 0 here, that's not how you do error handling when you return a pointer. If you're returning something, you need to return it. C. That gives me pause to think, well, wait a second. If something bad happens, do I return the memory address 1 telling you that you can find your bit vector over there in memory address 1? Does that sound right? Nope. When you're dealing with pointers and you're dealing with error handling, what is the only pointer that you can return to indicate that an error occurred? Null. Done. GCC everything again. Oops. All the way back. There we go. GCC that stuff. Compile that stuff. Run without valgrind to see that it actually works. 10, 40, 90, 160, 250. We're good. Ship it. Only 2 minutes left. All right. So, questions on that? So I'm getting a seg fault. What's the first thing you do? Go back. Did I compile with the wall flag? Did I take care of everything? What's the second thing you do? Run valgrind to see what's going on. At what line? What's the third thing you do? Fire up GDB at that line and find out what the hell is going on. Right? So find out eliminate everything with wall, find out where it's going wrong, use GDB to walk through and say what is going on. Right? Why is it failing? Right? Okay. Good luck on your midterm. It is due tonight at midnight, Central Daylight Savings Time, or whatever we're on, CDT. Right. Yeah.